Hi, I'm Rich with insideHPC. We're here at SE18 in Dallas, Texas. And today we're at the Asetek booth with Steve Branton once again. Steve, thanks for having me here once again.
Yeah, pleasure to see you again, Rich.
Well, let's start at the beginning for folks that might not know, Steve. Who is Asetek and who do you help in this HPC space?
So Asetek is a liquid cooling company, and what we do is help our customers who are primarily OEM manufacturers of computers deploy high-density clusters, particularly high-density clusters that are involved in AI using graphics coolers and the latest Intel CPUs.
And when somebody comes up, what is the story you tell about what you offer? How does it work?
Sure, Asetek's got three things to talk about. We're flexible, reliable, and proven. And when I talk about flexibility, what I'm talking about is how customers can use our solution to cool these dense clusters. And we actually have two solutions that we'll talk about today. Our in-rack lac and our in-rack CDU. So let's talk about in-rack CDU first. In-rack CDU is a product that allows people to take the heat that's generated by processors, CPUs, GPUs primarily, and get that into liquid, and then take that heat out of the data center in an all-liquid path, okay? And that is a very efficient way to cool things, and it allows us to cool very, very high-power processors in a very densely populated rack.
So Steve, that kind of solution would require plumbing, right? And water and all underfloor, et cetera, right?
That's correct. And that's one of the reasons that we've developed the second line, product in our line, which is the in-rack lac. That's a product for people who aren't quite ready to jump to the full liquid cooling solution, but still want to deploy high density equipment in an air-cooled data center. And so that's this product. And what it does is allow us to connect 12 cooling loops to a product that has radiator inside of it. So we're going to take the heat from the processors, bring it up to this box, and then the radiator in here will cool the liquid and send it back down to the servers. So the nice thing about these two products is they work with the same liquid cooler in the servers. So let's talk a little bit about that. Next we'll talk a little bit about proven.
By the way, when you reject this heat, is the air conditioning in the room, is that where the heat goes to?
Yes, absolutely.
Okay.
Yeah, so you can deploy it in any air-cooled data center.
So Steve, we started with the flexible. What do we got here?
So this is where we're talking about reliability.
Yeah.
And one of the things that we're very pleased about is that we have this business with Intel where we're the only liquid cooling provider that Intel uses to cool their own servers. We actually have two interesting examples here of technology. Both use the same pump cold plate system that's a core of our products. This one here on the left uses two Skylake coolers, and it rejects the liquid out the back of the server in via tubes.
Okay.
So that product will work with either the in-rack lac or the in-rack CDU. This product is interesting because here, this circuit board is shorter.
Yeah.
And that meant there was room to put a liquid to air heat exchanger inside the server.
Oh, cool. Okay.
So here, this is a standalone product. And what's interesting about that is because of this uniqueness, we were able to put the hex in here. But for most servers, they're dense like this. There's no space for the hex. And so what we've done is take that technology and then use the in-rack lac to work that in an air-cooled data center.
Wow. Okay.
And so we're very pleased to have the reliability stamp from Intel on these products.
So what's the third step then?
So the third step we want to talk about is proven. And let's walk over here.
Okay, Steve, we got a world map here with a lot of deployments, huh?
Correct.
Wow.
And we're very pleased to have 3 in the top 20 and 13 in the top 500. So it's a little bit of growth over the last time we talked. We've got the fastest supercomputer in Japan and the fastest supercomputer in Taiwan.
Got a lot of varied geographies, a really cold climate, all the way down to Singapore,
That's right. From
Yeah.
north of the Arctic Circle
Right.
to down to the equator.
Yeah.
And
Wow.
of course, they could throw away all the heat easily at Tromsø, but
Yep.
they have students they need to keep warm, so they are actually using the waste heat to recovering it
Yeah, okay.
and using it for heating. And of course, in Singapore, they're trying to avoid the cost of having to deal with air conditioning because electricity in Singapore is expensive. Also true in Japan and Taiwan, where we've seen good pickup.
Flexible, reliable, and proven at some of the world-class supercomputer centers in the world.
That's right. There's 13 in the top 500, so we're pleased with that statistic.
Well, Steve, this is a great story, and I love to see this grow because liquid cooling is the future. These chips are 300, 350 watts now, and it seems like there's no end in sight. Liquid cooling is the only way to get it done.